Okay, so here's a fun surprise I learned. So 3 wasn't that complicated, right?
Yeah.
4.
4.
Very complicated.
4 is
So let's just stay up at the top of the screen, so we'll give the surprise just by reading it out. What is 4?
so it's 1 plus a half plus a third plus a fourth plus a fifth.
Plus, when does it
plus
start
five,
jumping?
All the way up to a 30th
A 30th it starts jumping.
plus a 200th
Uh-huh.
plus a 1 over 77,706
Yep.
plus 1 over 16,532,869,712
Okay, plus?
plus what is that?
What is that number?
So it's trillion sextillion.
Okay, 3 sextillion, let's see, is it? So there's thousand, million, billion, trillion, quadrillion, quintillion, sextillion. And then whatever in the world this number is down here at the bottom. Let's see, thousand, million, billion, trillion, quadrillion, quintillion, so quintillion, right? 5, 6, 7, 8, 9, 10, 11, 12, 13.
13 million.
Whatever that is, 36, I don't know. I don't know what it is at 13.
36 times 10 to the 13th.
Yeah.
Pretty much.
And that is what gets you to add up to 4. Now, hopefully this shows up on the computer screen. So once you started jumping here from 30 to 200, let's look at those denominators.
Numerators.
Or sorry, numerators. It was first 11 billion,
Then 29 million.
29 million,
Then 2,000.
then 67,
And then what?
then 1. So that's what Radcliffe noticed, is that those numerators, I hope I didn't say denominators before. Yeah, I feel like I did. Numerators. Those numerators start decreasing once you start jumping.
Yeah.
And obviously, at the beginning, when you're not jumping, they can increase. It goes from 3 to 5 to 13 to 23 to 103. They're not, but once you start jumping, the numerators decrease, which is pretty cool. And it looks like actually that they start decreasing pretty quickly.
Yeah.
But I don't know if that's always going to be true. So that's where we get to with 4. Now, if I try to add up to 5, I don't even think this ridiculous big number I've picked even does it. I don't think you get to 5. Yeah.
What?
So
Wait, what?
we haven't even gotten there yet, and that the numbers are so big that they actually go off the screen.
So it's like, it's 2.4 times 10 to the 556?
Yeah. So and we're not even there yet, right?
Yep.
Yeah.
Right. Although the numerators are decreasing, so we're actually getting close. But we could probably just sit here and just add zeros to this number. Yeah. La 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 la. Adding zeros, adding zeros, adding zeros. I don't know. Well, you said it needed 556?
Yeah.
So that's probably going to be a lot. Like if we just kept adding zeros for, I don't know, an hour.
We might get there.
We might get there.
How about now? Let's try it, I guess.
All right, let's try it. Let's see what happens. See what's down at the bottom here. No.
An even huger number.
1,113.
10 to the 1,100.
Yeah, so we don't even, it looks like we might be able to get to 5 at some point.
At some point, but
Not yet.
This
you need a
program
ridiculous amount of zeros.
You set this program to add zeros for like a whole day.
Yeah, so you start jumping when you get to 82. Is that on screen? Yeah,
Yeah.
You start jumping when you get to 82, then 101, then 12,000, then the numbers get like so big you can't read them. You can't even pretend to be able to read them. In fact,
No.
yeah, the numerator is still 2 quadrillion or 2 quintillion on that one.
Wow.
But it's neat. So even though this is a great example of sort of an existence idea,
Yeah.
Dave Radcliffe gave a procedure showing how to do this. We know we can do it, and because those numerators are decreasing.
Yeah.
And
It's hard to do it, though.
it's still hard to do it, but once you know you can do it, you can do it.
Add zeros.
But even adding up to 5 is
Very
surprisingly hard.
Yeah.
Yeah.
Anyway, this is fun. This is a good plan with this suggestion. All right, good work, guys.